All right, so diving in today, we're going to be talking about pole shifts. Um, I'll be honest, this one's a bit out there for me. It feels like some kind of straight out of a cheesy disaster flick.
Yeah, a lot of people think that. It's a topic that's definitely captured the imagination for a while, but, separating fact from fiction is really important, and that's where our deep dive kind of comes in.
Okay, so less end of the world and more real science then. I'm all ears. But where do we even begin with something like this? Seems pretty complex.
Well, let's lay some groundwork first, I guess. We need to be clear about the difference between geographic poles and magnetic poles. Like, think of geographic poles as marking those points where the Earth spins on its axis, right? Those don't shift very easily.
Okay, so the actual top and bottom of the planet. Got it. But I keep hearing about these poles flipping. Is that what we should be worried about?
Well, that's where the magnetic poles come in. They're the ones that, govern our magnetic field, the one that makes compasses point north. And those poles, yeah, they do move around a bit. They've even totally reversed in the past.
Hold on, reversed? Like north becomes south and vice versa?
Yeah.
How is that even possible?
Yeah, it's a real thing. Scientists call it a geomagnetic reversal. And get this, it's happened hundreds of times throughout Earth's history.
Wait, hundreds? So how often does this flip thing happen? Is it like sudden, like a light switch? Or more of a slow process?
Definitely less of a light switch, more like a slow dance. Geomagnetic reversals, they take thousands of years to unfold. It's not some, sudden catastrophic event.
So no instant planetary chaos then. That's, it's good, I guess. But how do we even know this has happened before? It's not like anyone was around, millions of years ago taking notes.
Right, that's where the detective work comes in. Scientists, they look at rocks and ocean sediments. They've got these tiny magnetic particles in them that act like little compasses, aligning themselves with the Earth's magnetic field, back when they formed. By studying these, we can kind of get a glimpse into the past.
That's pretty clever. So these rocks are like time capsules, revealing the direction of the magnetic field from ages ago. Okay, back to these reversals. What actually goes on during one? Does the Earth's magnetic field just poof vanish?
Not quite. It weakens and kind of gets more complex during a reversal. Instead of a single north and south pole, you might have multiple magnetic poles kind of popping up.
Multiple pole. That sounds kind of messy. What happens then? Does the world just lose its magnetic protection?
Well, that magnetic field, it's crucial. It shields us from all that constant stream of charged particles the sun throws at us. A weaker field means less protection. But even during reversals, the field doesn't completely disappear. It's more like it gets a little wonky.
Wonky is one way to put it. So we're not talking about instant planetary doom, but what are the effects of a weaker magnetic field then? Does it affect our technology or even life on Earth?
Well, yeah, exactly. Let's start with technology. Think about things like power grids, communication systems, all our satellites up there. They all rely on a stable magnetic field. A weaker field or a really erratic one could lead to, disruptions, maybe even damage.
So more blackouts, communication glitches, or GPS going haywire, not exactly ideal. What about the impact on life itself? We're talking doomsday scenarios there too.
Well, life on Earth's been through a lot of magnetic reversals, But there are potential impacts. Increased exposure to cosmic radiation is something we got to think about. Some studies say this could lead to a higher risk of certain health problems, but we need more research on that for sure.
Okay, so not like, everything dies off. That's good to know. But still, it all sounds like a pretty big deal. How likely is all of this, really? Should I be prepping for the apocalypse?
Well, let's take a breath and separate the Hollywood hype from the science. We know these reversals have happened before, but, predicting the next one is, it's tricky. We can't say for sure when it might occur or even how intense it would be.
All right, so no need to panic just yet. But gotta admit, all this talk about magnetic fields and solar winds is making my head spin a bit. What I really want to know is, could this lead to, a true pole shift, the kind that sends continents scrambling, throws the whole world into chaos?
That's a common question, and it takes us back to that difference between geographic and magnetic poles. Remember, the geographic ones, they mark the Earth's spin axis, the deep down structure of the planet.
Right, the actual poles, not just the magnetic ones. So are those going anywhere?
Well, there's this concept called true polar wander. It's where the Earth's crust can actually shift a little relative to the axis of rotation. But this process, it's incredibly slow. We're talking millions of years here.
Millions. So we're talking geological timescales, not something we'd see in our lifetime.
Precisely. The geological evidence shows that any shifts in the Earth's axis have been, really gradual. Nothing sudden or catastrophic like you see in the movies.
Okay, so no continents suddenly swapping places.
Yeah.
That's a relief. But what about all those claims that the Earth's magnetic field is getting weaker and that this means a pole shift is like right around the corner?
It is true that the Earth's magnetic field's been weakening over the past few centuries, yeah. And the magnetic North Pole has been moving at a faster pace, too. Scientists are definitely studying these changes closely.
So does that mean a reversal's about to happen? Are we on the brink of some magnetic mayhem?
Well, it's tempting to think that, but it's not that simple. You see, the Earth's magnetic field is complex. It's constantly changing. While the current trends are, interesting, they don't necessarily mean a reversal is right around the corner.
Right. So it's a wait-and-see situation.
Yeah.
But what if a reversal did happen? What would that mean for us?
That's exactly what we'll explore more in our deep dive. We'll look at the potential impacts on technology, life, and what we can do to, get ready for a world with a wonky magnetic field.
All right, I'm ready. Bring on the wonky magnetic fields. But seriously, this is fascinating stuff. I'm actually starting to see why pole shifts capture people's imaginations. It's not just about disaster scenarios. It's about understanding those powerful forces at work within our planet, right?
Exactly.
Yeah. And by understanding these forces, well, maybe we can better appreciate our place in this, dynamic and ever-changing world. Stay tuned. We're just getting started. So we've established that like a sudden catastrophic pole shift is more fiction than fact. But a magnetic reversal, well, that's something, we know has happened before. And it could, happen again.
Right, and it sounds like even if it's not an instant planet ender, yeah, there could be some real consequences, especially for all our fancy technology. Kind of makes you realize how much we depend on all that stuff, huh? It really does highlight our vulnerability, yeah. I mean, think about it. Power grids, they're designed for this stable magnetic field, right? And satellites, they're orbiting up there in this predictable magnetic environment. And communication systems, well, those rely on the satellites. A magnetic reversal really throws a wrench into all that.
Yeah, okay. So maybe it's time to ditch the smartphone and stock up on canned goods, right? But seriously, what can we actually do to prepare for a world with, a wonky magnetic field?
Well, panic buying probably isn't necessary. But thinking ahead, that's always smart. On a societal level, we're talking about building a more robust infrastructure. Imagine power grids that are designed to handle the fluctuations of a weaker magnetic field or a really erratic one.
This is like a power grid that's less likely to have blackouts, even if there's like a solar storm or something. Sign me up to that. But what about the satellites? Seems like they're just sitting ducks up there if the magnetic field goes, haywire.
Yeah, satellites are definitely vulnerable. We're talking about, designing them with better shielding against radiation, maybe even creating backup systems that can take over if a satellite, goes down.
Makes sense. And what about us, regular folks? Anything we can do, like on an individual level, besides maybe brushing up on our compass skills?
Being prepared is always key, right? No matter what the situation is. But in this case, staying informed, that's crucial. Think of it like checking the weather forecast, but for space weather.
Space weather forecast. Is that a real thing?
Absolutely. There are agencies that monitor solar activity, and they can actually predict, geomagnetic storms. Knowing when a storm is likely to hit, well, that could help us prepare, right?
Interesting. So instead of checking if it's going to rain, I'm checking if the sun's going to, throw a tantrum. What would we even do with that information, though?
Well, imagine you knew a big geomagnetic storm was coming. You might charge up all your devices, have some cash on hand in case ATMs go down, maybe even stock up on a few essentials. It's all about being ready for those potential disruptions.
Okay, so basically treat it like a hurricane or a blizzard, but coming from space instead of the clouds.
Okay.
Makes sense. But you mentioned health risks earlier, too. What's the deal with that? Should I be investing in a lead-lined hat?
No need for extreme measures like that. The Earth's atmosphere, it does a pretty good job of filtering out most of that cosmic radiation. But with a weaker magnetic field, well, more of that radiation could reach the surface.
So more exposure to radiation, huh? That doesn't sound great. What are the risks, and how can we, protect ourselves?
Scientists are still they're still researching the exact effects, health effects, of being exposed to higher levels of radiation over a long period. But taking some, simple precautions during a big solar storm or during a period of weakened magnetic field, well, that could be wise.
Like what? Give me some practical tips.
Well, think about limiting your time outdoors, especially at higher altitudes. That's where the radiation levels are higher. Sunscreen, protective clothing, those are never bad ideas either.
So basically the same kind of precautions we take for sun protection, but for a different kind of radiation.
Exactly. It's about being aware of the risks and, making informed decisions.
That makes sense. But what really blows my mind is how scientists figure all this stuff out in the first place. How do we even know about magnetic reversals that happened millions of years ago? It's not like there were any witnesses.
Right, but the Earth itself, well, it keeps records. That's where things get really, really fascinating. Scientists, they study rocks and ocean sediments looking for clues about past magnetic fields.
Wait, rocks can tell us about magnetic fields from millions of years ago. Yeah. How does that even work?
Remember those tiny magnetic particles we talked about earlier? The ones that act like little compasses, aligning with the Earth's magnetic field. Well, those particles, they get locked into place when rocks form or when sediments settle on the ocean floor.
So it's like a snapshot of the magnetic field frozen in time.
Exactly. And by studying those particles, well, scientists can figure out the direction and strength of the magnetic field from millions of years ago.
That's incredible. So by digging into the Earth, we can actually piece together a history of the planet's magnetic field, like a magnetic time machine or something. Mm-hmm. What have scientists learned from all this digging and analyzing?
A lot. They've discovered that magnetic reversals, they're not evenly spaced. Sometimes they happen pretty frequently, and then other times there are these long stretches of stability.
So there's no way to predict when the next one might hit. It's kind of like waiting for the magnetic roulette wheel to stop.
Pretty much, yeah. We know that on average, reversals happened, every 250,000 years or so over the past million years. But that's just an average. It could happen tomorrow, or it could be millions of years away.
Okay, so the mystery remains. But I'm guessing all this research helps scientists understand how these reversals work and what kind of impacts they might have, right?
Absolutely. By studying past reversals, they can build models, and then they can make predictions about what might happen during the next one.
Predictions, huh? So what are they saying? Any big insights about what a future reversal might look like?
Well, one thing they've learned is that magnetic reversals usually happen pretty gradually, over thousands of years. That means we're not talking about a sudden overnight shift in the magnetic field. It's a slow process.
Okay, so that's good news. Gives us some time to adjust, maybe even come up with some clever solutions. But what about the strength of the magnetic field? Does it just kind of gradually weaken during a reversal? Or are there any surprises along the way?
That's where things get even more interesting. It's not always a smooth decline. The magnetic field, it can fluctuate. Sometimes it weakens in one area and then strengthens in another. And there can even be periods of really rapid change within the overall reversal process.
So it's not just a dimmer switch slowly turning down. It's more like a light show with all sorts of unexpected, flickers and bursts.
That's a great analogy. And those flickers and bursts, that's what scientists are really trying to understand better. They're looking for patterns, trying to figure out what's driving these changes.
I bet that's like solving a giant magnetic puzzle or something. But it sounds crucial if we want to be prepared for what a reversal might, throw our way.
Exactly. The more we know about how the magnetic field behaves during a reversal, well, the better we can anticipate the impacts and develop strategies to mitigate them.
So it's not just about understanding the big picture of a magnetic reversal. It's about getting down to the the nitty-gritty details, the flickers and bursts, the regional variations, all that stuff. It really matters.
Absolutely. It's those details that could help us protect our technology, our infrastructure, and ultimately ourselves.
This is getting it's getting pretty deep, even for a deep dive.
Yeah.
But I'm curious about something else. Earlier, you mentioned that the Earth's magnetic field acts like a shield, protecting us from all that solar radiation. But how exactly does that work? I mean, it's not like there's a giant force field surrounding our planet.
Yeah, right. It's not a visible force field like in the movies, but the Earth's magnetic field, it extends way out into space, and it creates this protective bubble around our planet. We call it the magnetosphere.
The magnetosphere, huh? Sounds impressive. So how does this invisible bubble, shield us from the sun's radiation?
Think of the sun as constantly emitting this stream of charged particles. It's what we call the solar wind. And when those particles reach Earth, well, they run into our magnetosphere. And most of them, they just get deflected, like a magnetic force field pushing them away.
So it's like an invisible shield deflecting all those harmful particles before they can reach us.
Exactly. It's an incredibly effective shield, protecting us from the worst of the sun's radiation. But there are times when the sun gets a bit more active. It throws out these bursts of energy and particles that are much stronger than the usual solar wind.
Okay, now you're making me nervous again. What happens when the sun throws one of those tantrums? Does our shield hold up?
It usually does, yeah. But those powerful bursts, we call them solar storms or coronal mass ejections, they can sometimes overwhelm the magnetosphere.
Uh-oh. So even with our magnetic shield, we're not completely immune to the sun's bad moods.
Well, unfortunately not. And that's where things get a bit tricky, especially during a magnetic reversal. When the magnetic field's weaker and more erratic, those solar storms can have a bigger impact.
Oh, I see where you're going with this.
Yeah.
So if the sun throws a tantrum while our magnetic shield is down, that's when things could get really messy.
That's right. It's kind of like having a weakened immune system during flu season. You're just more vulnerable to getting sick.
Okay, so it's a combination of factors: the strength of the Earth's magnetic field and the activity of the sun. They both play a role in how much radiation actually reaches us.
Exactly. It's a complex interplay between these forces, and scientists are still working to fully understand all the nuances.
It sounds like a pretty challenging job. But thinking about all this, it really makes you realize how interconnected everything is. The Earth's magnetic field, the sun's activity, our technology, even our own health. It's all tied together.
It is a powerful reminder of our place in the universe. We're not just separate entities. We're all part of this intricate and dynamic system.
It's humbling for sure, but it's also inspiring. It makes you want to learn more. To explore, to figure out how to navigate these challenges and create a more sustainable future.
I couldn't agree more. And that's what we're going to keep exploring in our deep dive. We'll look at the specific impacts of magnetic reversals on our technology, our environment, and even our own bodies.
All right, bring on the knowledge. I'm ready to dive even deeper. This is turning out to be a lot more fascinating than I expected.
Stay tuned. We're just getting started.
Okay, so my brain is officially full of magnetic fields and solar winds at this point. But before we wrap up this deep dive, I've got one more burning question. Let's say a magnetic reversal does happen. What would that actually look like from our perspective here on Earth?
Yeah.
Would the sky light up? Would compasses spin wildly? Would continents start drifting apart?
Well, the good news is it wouldn't be quite as dramatic as Hollywood might lead you to believe. You probably wouldn't see continents ripping apart or the sky catching fire or anything like that. In terms of visuals, the most noticeable change might be the auroras.
Auroras? You mean the northern lights? I've always wanted to see those.
Exactly. Those stunning displays of light, they're caused by, charged particles from the sun interacting with the Earth's magnetic field. And during a magnetic reversal, when the field is weaker and more complex, well, those auroras might become visible at lower latitudes.
So people who normally wouldn't get to see the northern lights, they might suddenly have a chance to to catch them. That's pretty cool. But what about the more the more practical stuff? You mentioned compasses earlier. Would they still work during a reversal?
Compasses would still function, yeah, but they wouldn't be pointing to the same north that they do now. Remember, during a reversal, the magnetic poles flip, so a compass needle would actually be pointing towards the geographic south pole, which would become the new magnetic north.
Wait, so my compass would be pointing south, but everyone would call it north. Wouldn't that get confusing?
It would definitely require some adjustments, yeah. Navigation would be, it would be interesting, to say the least.
I bet. Imagine trying to explain that to someone who didn't know about, magnetic reversals. They'd think you were crazy.
It's a reminder that our whole idea of north and south, it's really based on this magnetic field. And it's not as constant as we might think.
Yeah. Mind-blowing stuff. But let's talk about the less glamorous but potentially more disruptive impacts. What about all our technology? Would a magnetic reversal really wreak havoc on things like power grids and communication systems?
Well, there's a real possibility of that happening, yeah. Remember, a weaker and more erratic magnetic field means less protection from those solar storms, and those storms, they can induce some powerful currents in our electrical grids, and that can cause blackouts.
So imagine those widespread power outages we see sometimes during big storms, but on a much larger scale, and maybe lasting for much longer. That's not a pleasant thought. What about our communication systems?
Yeah.
Those rely heavily on satellites, right?
Yeah.
Exactly. And satellites, well, they're orbiting outside the protection of our atmosphere, so they're especially vulnerable to solar radiation and those charged particles. During a magnetic reversal, we could see a lot more satellite malfunctions, disruptions to GPS navigation, and even interruptions to our communication networks.
Okay, starting to get a picture of how this could really impact our daily lives. No more GPS, spotty internet, maybe even losing power for days or even weeks is making me appreciate the stability of our current magnetic field. That's for sure.
It does make you realize how much we take for granted, but it's also a bit of a wake-up call, I think. We need to start thinking about ways to make our technology more resilient, to design systems that can handle the challenges of a magnetic reversal.
So it's not just about waiting for a reversal to happen and then scrambling to deal with the consequences. It's about being proactive, about preparing for a future where our magnetic field might not be as reliable as it is now.
Exactly. It's about understanding the risks, adapting our technology, and really, building a more resilient society, one that can weather these kinds of changes.
Well, this has been an incredible deep dive. I got to admit, I started out thinking this was all a bit far-fetched, like something out of a sci-fi movie. But I've learned so much about the Earth's magnetic field, the sun's influence, and the potential challenges we might face in the future.
It's been a pleasure sharing this exploration with you, and I hope our listeners, have gained a new appreciation for those invisible forces that really shape our world, and the importance of understanding and preparing for the changes that lie ahead.
Absolutely, it's a reminder that knowledge is power. The more we understand about our planet and the universe around us, well, the better equipped we'll be to navigate whatever the future holds, right? So to everyone listening, stay curious, keep exploring, and never stop questioning.
And until next time, keep diving deep.